Now here I have an RC series circuit, so capacitor and a resistor, and I'm looking at on my oscilloscope. I'm looking at Vs, okay, so tallest one, and I'm looking at Vc. Now, of course, Vc is a bit lower, but what I want here to look at is the actual phase angle. You see that in that case, Vs leads Vc. Remember that Vc lags the current in a capacitor by pi over 2. So here I have a capacitor and the resistor. So the resistor is in phase with the current, and Vc lags by pi over 2. So when you do Vs, which is the sum of Vr vector plus Vc vector, you get a right angle triangle, and your Vs is somewhere in between Vr and Vc, and that's what you find here. So really, if we had Vr, okay, so remember full period, I have a full period of 10 division, okay, so a quarter would be 2.5. So really, if Vr was here, Vr would be crossing here at 0. Vc, you see, is here at a quarter of a period, which is pi over 2, and Vs is somewhere in between. You see that at 100 Hertz, when the frequency is low, the voltage across the capacitor is high, and Vs and Vc are close to each other. Okay, if I put 50 Hertz here, okay, so this time I have only one cross, 1/2, and you see my phase angle is getting smaller. Okay. Now, if I do the opposite, if I increase, so if I go to 100 first, okay, so of course 100 Hertz, so I have twice as many sine waves in the same amount of time. So Vc, the distance between the two of them is going to get smaller. Bigger. So 500. Okay. So see, the distance is getting bigger. So I'll change my horizontal just so we can see bigger. Okay. So the distance between the two of them is getting bigger. So the angle is getting bigger. And Vc, the peak value of Vc is getting smaller. I'll go to 1000. Again, Vc is getting smaller, and the phase angle is getting, so again, if I put 2.5, okay, see, it's getting here in the middle, 10,000. Okay, now I just adjust that again. Oh, it's very hard to see, touch position. Yeah, the position is right. Okay, so the actual angle is increasing as I increase the frequency. So it means my Vs is getting closer to Vr, away from Vc and closer to Vr, and Vc is going down. So it means that proportionally Vr is getting bigger. So Vr is getting close to Vs, and Vc is getting close to 0. When I go the opposite, okay, remember at the beginning, adjust here, so now I have only 100 Hertz again. At the beginning, you see here, Vc is close to Vs, so it means in opposition, Vr is going to be small.